Today in class, you did a graphing exercise where you learned about different types of graphs and what kinds of graphs to use for different data. So these notes are going to wrap up how to create a good graph. Before we dive into the particular types of graphs and how to create a good graph, let's take a look at your data. So the first question is, how do I organize my data during an experiment? Because good data organization is going to allow you to see the trends and patterns in your data and help you to answer the question that's being asked. So when scientists design an experiment, they're usually looking for a cause and effect relationship between the independent variable and the dependent variable. So, if you're talking about, plant height versus how much water you give them, it would be a cause and effect relationship. How much water is going to cause the plant to grow, the best possible. So we have this cause and effect relationship between the independent variable and a dependent variable. So let's take a look at the difference between the two. So an independent variable is the variable that stands alone, is not changed by other variables that you're trying to measure. All right, so your independent variable in our plant situation would be the how much water. Another way to think about an independent variable is that's the one that you control in the experiment. All right, so your independent variable is the one that you control in the experiment. And if we're talking about plant height versus water, you're controlling the amount of water given, okay, during the experiment, but you have no control over the plant height. Okay, so an independent variable is the variable that stands alone, not changed by the other variables because you control it. In fact, let's write down you control it. Okay. Now, the dependent variable is the variable that depends on the other factor. It depends on the independent variable. So in our plant height versus water, the plant height is going to depend on the water. So the plant height is the dependent variable in that experiment. Okay. So when you're organizing your data, it's easiest to think about what's my independent variable and what's my dependent variable, and to organize your data by the independent variable. Okay, that way you can easily see relationships that might be apparent. So in our plant, plant scenario, you're going to want to organize your data by how much water you give them. 1 milliliter, 2 milliliter, 3 milliliter. So that should be how you organize it versus, in order of plant height. You may not be able to see the trends as clearly as if you organize it by your independent variable. So if we take a look at the data tables on the right, these are the same data tables that you saw in the POGIL activity. And you can see between volume and mass, the volume is the independent variable, and so it is easier to see that as volume increases, mass increases if you put it in order of the independent variable, which is volume. If you take a look at the top, you can't really tell that volume is going to increase, mass is going to increase with volume because it's kind of all over the place. So this bottom one here is better organized. So organize your data by the independent variable. All right, so now that you've got your data nice and organized and you're able to see your trends and patterns that might be emerging, now we can talk about representing your data in a graph. So one of the questions that you should be asking yourself is, what type of graph should I use? So scientists use graphs to clearly illustrate whether there is a relationship or not between variables. So for most cases, you're going to use a scatter plot, which is like a dots and lines kind of graph. But you can use bar graphs. There are two basic reasons why you would use a bar graph. Okay, so only use a bar graph if these two things are occurring in your data. The independent variable is non-numeric. Okay, meaning that what you're controlling is not measurable with numbers. It's like sorting by color or sport type, okay, or maybe a range of height or something like that, where it's non-numeric, and so you can't really, graph numbers in a sense. So use a bar graph if your independent variable is non-numeric, all right? And you could use a bar graph if you want to show how often something happens, right? So frequency. If you are, counting up the number of red cars that go by the street versus the number of blue cars that go by the street, putting it in a bar graph would be a really good idea. So you can do, if you want to know how, a frequency, if you want to know how often something happens, you can use a bar graph. All right. Otherwise, all your other data, and I'll tell you right now in this class, 99% of the graphs you make will be scatter plot, dot and line graphs. Okay, so you're hardly going to make bar graphs in this class. So just kind of get used to making dot and line graphs. Okay, so we've talked about data organization. We know which kind of graph we're going to use. Basically, a scatter plot. So now let's take a look at putting together a good graph. All right, so the first thing you need to figure out is the graph axes. So we have an x-axis and a y-axis. Remember, the x-axis is along the horizontal, and the y-axis is the vertical, right? So just like in math, x and y-axes. So to figure out which one you're going to label, you need to ask yourself which variable depends on the other, right? So remember, in our plant versus water, the plant height depended on the amount of water. So in that case, we had the height, which was the dependent variable, and the water, which was the independent variable, right? So we would, in a graph, you always put the independent variable on the x-axis. Okay, so our water then would go on the x-axis, and our height, our dependent variable, would always go on the y-axis. Okay, that way you can clearly see that if, as something increases, are you going to see an increase of what's going on, or will you see a decrease, okay, in your thing? It'll be a nice, easily shown. All right, so x-axis gets the independent variable, y-axis gets the dependent variable. All right, so when you are labeling your x and y axes, please, please, please don't forget to label them. You need to label it with the name of the axis, like height, okay, or amount of water, and then you also need to put a unit, because we're always measuring in some type of unit. So height, maybe in centimeters, and water in milliliters. But you always want to make sure you have both the name and the unit. If you're missing one or the other or both, you definitely are going to get points marked off of your graph. So make sure you take the time to label with a name and a unit. All right, so once we've labeled our x-axes and our y-axes, our independent variable and our dependent variable, now we got to think about numbering your axes. All your data in a graph is going to be numerical, and so you want to choose appropriate scaling for your x and y axes. If you have a small range of numbers, like for example, if the height range only went between 30 to 40 centimeters in your plants, right? You want to use a scale that's not too big. In your graph, you don't want to go from 0 to 100, okay? That would be too big of a scale, right? You'd probably, you want to choose a lower number. In fact, you may not even want to choose from 0 at all, because your graphs do not need to start at 0, 0. All right, yes, in math, when you're doing your x and y axes and 4-quadrant graphs, then obviously you need to start at 0, 0. But a lot of times for your scientific data, you don't necessarily need to start with 0, 0 as the corner there. So you could, for example, if your heights is between 30 and 40, you could have a graph, okay, that starts with 30 and it goes, by, decimals if you want, 30.5, 31, 31.5, etc., so that you can see a real good space out of those numbers so that your trend or your pattern is clearly seen in your graph. Okay. But you do want to make sure that you don't mislead your audience by choosing the wrong scale. Okay. So for example, if you take a look at this SAT graphs here, both of these graphs show the exact same data. All right. Both of them show the exact same data. The only difference is the scaling. All right. If you take a look at the scaling, this shows a lot more detail in scaling than this, right? And so if you look at the data on the left, it looks like in all of these colleges, most of the freshmen come, in with about the same average SAT score. All right. However, if you look on the right, there's a vast difference, okay, between the SAT score of the average incoming freshman. All right. So we don't want to mislead our audience and saying, oh, look, it doesn't matter if you're going to Yale or, UCSD or something like, or, MSJC, everybody has the same, SAT score, okay, which would not be the case, all right? So make sure you don't mislead your audience by choosing the wrong scaling. Your next step in graphing is plotting. All right, and this is where a lot of the mistakes occur. So please be sure you slow down and double check your plotting. All right, make sure you're doing accurate plotting of your points, because if you plot the wrong points, you will then have this face and you'll have to do it all over again because it'll lead you to the wrong analysis of data. Okay, so make sure that you slow down in plotting your points, and you always double check. Last but not least, you want to make sure that your graph has a title. All right, if you had a graph of something versus something else and there's no title to tell you what is going on, all right, then your audience is not going to know what your graph is about, especially if you don't label your X and Y axes either. Then they have no clue about what you're talking about. So make sure you always title your graph. Your graph title should include both variables that are measured. Okay, so for example, in the graph on the right, this is the cost of average speeding ticket versus the automobile speed. Okay, so as you can see, as the automobile speed increases, your cost of the speeding ticket increases. So a good title could be one of these. The dependence of a traffic ticket cost on automobile speed. Again, it includes both variables, cost and speed. Or you could just do very simple one, right? Cost of average speeding ticket versus automobile speed. Okay, typically in that sense, you're always going to do your dependent variable and then have versus your independent variable. Okay, is the order that it goes on. All right, so in fact, that's what this last one says. If you can't think of anything else, anything fancy, cutesy, whatever, then just do plain old y-axis versus x-axis. Dependent variable versus independent variable, and you'll get credit for that every time. All right, so I hope this helps with creating a good graph from your data. You'll be doing it often in class with your data, and so having a good grasp on how to do this well is going to be important.